Hello, welcome everyone. My name is Leela Rhodes and I'll be your moderator today. Thank you so much for joining us here at NetCom Learning, a market leader in promoting lifelong learning, training, and talent development solutions. We are very excited to host today's event, Microsoft Azure Data Fundamentals Masterclass. And presenting today's topic is Brent Dawson, a driven Microsoft certified trainer with over 20 years of experience. Brent is also a Microsoft Dynamics architect out of London, UK. He has delivered comprehensive Microsoft infrastructure and security trainings, giving his students the tools they need to build, maintain, and secure their Microsoft network infrastructure. Bringing over 10 years of experience as a solution and infrastructure architect, he has been responsible for architecting Microsoft-based solutions in Azure, Dynamics 365, SQL, and SQL Server. Now, please bear in mind that this is just an overview of a very robust topic, and we do offer a collection of technical and business courses that can be tailored towards your specific requirements. If you're interested in a further discussion, you can make an appointment with our learning consultants through our website at www.netcomlearning.com. Today's session is also being recorded, so you will get free access to the recording in the next 24 hours via email. NetCom Learning helps customers build innovative learning organizations by achieving a smarter workforce, adopting change, and driving growth. And we do this with a broad catalog of offerings, developing customized learning plans, and our global delivery capabilities. Since 1998, we have been empowering organizations with our managed learning services to help them reach optimal performance results and address challenges. We have 9 practice areas in which we specialize. They encompass people, process, and technology training. And today's presentation is from the Data and AI practice area. NetCom Learning offers a comprehensive training portfolio for data and AI courses, and our upcoming courses and classes include various trainings on DP-900 T00, AZ204 T00, AI 102 T00, and many more. And also private team trainings for these are also available, and the learning plans can be customized to the specific needs of that audience. You can also access a variety of data and AI marketing assets, such as our free 1-hour training, our free trainings by clicking on the available webinar handouts. And these offerings can also be found with a simple search on our website at www.netcomlearning.com. In this session, learners will uncover all aspects of DP-900 certification course and exam, and they will also get a chance to explore the relational and non-relational data offerings, as well as big data and modern data warehouse analytic solutions in Azure. And now I'm just going to give you a quick overview of the logistics before we do get started today. To start with, you have the option to adjust your window size to whatever size you like. You can simply hit the escape key and find the zoom button on the top left corner of your GoToWebinar viewer. Everyone has been muted except for our presenters, but you can feel free to submit any questions you have for the presenters in the questions panel, and we will address them at the end of the session today. Also, to get the best out of today's webinar, we've included the slides, courses we've talked about, and marketing assets in the handout section of your GoToWebinar viewer, and you can refer to those at any time to get a better understanding of the topic. And now, without any more wait, I'm going to go ahead and pass the time over to Brent to present today's topic. Thank you so much for joining us.
Right about that. So that's all makes everything good. So today we're going to take a look at at the DP-900 or the Data Fundamentals class. So we're going to take a look primarily at sort of the ideas behind core data concepts. So first of all, understanding how Azure works, how Azure stores information, and then also from there we're going to do some concepts relating to both relational and non-relational data services in Azure, and sort of the standard and fundamentals of how that actually works. And then we're going to take a look at some of the modern warehouse features that exist in the Azure platform. Okay. So first and foremost, Azure has a data storage capacity or capability that allows us to put data into a data system, database, file shares, what have you. The basic understanding of this is that there are two different types of file storage that can be used for databases in the Azure cloud, depending upon which implementation of the database system and or what type of data you're storing. So first of all, there's the concept of what's called blob storage. So blob storage is just more or less standard basic file share storage. And so if you're putting a database file that you actually had on premise into the cloud, and you create a virtual machine that has a SQL Server installation on it, or Oracle or some other language on it, you will use that file share to actually store the database file, the VHD, or sorry, the database file that will be attached to that virtual machine. And so you'll just consume that blank storage as it grows and grows and grows and grows. If, on the other hand, you decide to use what's referred to as Azure SQL, or any of the other SQL flavors that's available in Azure, such as Cosmos DB and NoSQL and some of the other ones, then you'll be able to use actual SQL storage, which will be faster and requires that you don't actually have to install a SQL Server version into Azure. It just runs sort of at the Azure platform level, known as a SaaS, or software as a service. And at that point, we can go ahead and store the information that way. There is cost, of course, with all storage in Azure, so there is any cloud storage configuration. But depending upon how much data you have and how you're going to access that data will determine how you're going to utilize and consume that data space. So now that we've sort of got the platform fundamentals out of the way, the next thing we need to do is we need to take a look at data. So for the rest of the presentation, we're going to be looking specifically at the type of transactions and processing that we can use with data inside of the database system. So if you have any background in databases, or have installed anything before, like Access or even, you should have be able to follow along and understand what we're referring to. So the first thing we need to look at is the concepts of transactional versus analytical data. So an OLTP, or online transaction processing database, is generally going to be what we would refer to as your live system, right? So this is the one that everybody would be connecting to, putting all their data in. So if it's an order comes, like say you have a sales desk or something, and somebody calls in and they place an order, then that order will get written to the online system or to the live system, and this is using what is referred to as transactional processing. So these transactional processes are how data is stored based on each transaction one at a time. Now, when we are creating transactions within the system, we actually do two processes. The first one is that we record the information into a log. So there's something in the system called a transaction log. That transaction log records all of the contents of the transaction that was executed one line at a time. The reason that we have a transaction log is so that if, for whatever reason, we lose data, or we lose access to the database, or the database becomes corrupted, we can use that transaction log to get us back to a stable state, so that the data that potentially could have gone missing is actually recorded in the transaction log. And that makes life a lot easier for the data managers or the DBAs, because obviously you want to be able to get the data back in the system and have the system up and run as fast as possible. The other thing that happens is that there's a back-end cache, I guess is the best way to put it, in the Azure platform that backs that transaction log up constantly. So it allows you to do something such as point-in-time recovery. So as an example, if you have a transaction that you've written at 12:01 p.m. and the database server goes down at 12:01 and 30 seconds, because that transaction has been recorded in the transaction log, when you bring the database back up, you can restore to that specific transaction. Or if you have a transaction that actually caused the database to become corrupt for whatever reason, you could do a restore of that database to the point in time one transaction prior to the one that caused the database to become corrupted. So it does give you the capabilities of making sure that you do have very stable implementations of your network. But the key here is that when we're doing transactional data, data is stored one transaction at a time. So it's first in, first out. It doesn't do multitasking in the sense of being able to write multiple things at the same time. It's whatever comes into the log first gets written to the database itself. The other type of data that we have and is quite commonly used is analytical data. So analytical systems, or OLAP systems, online analytical processing systems, are data that has been aggregated and periodically loaded into things such as cubes or data marts. But generally, these are going to be put into what's better known as a data warehouse. In a few slides, we're going to talk about some of the capabilities that the system has to make life a lot easier. But we will talk about this concept of normalization later on. But the whole point of an online analytical system is that it helps to make sure that the data is easily accessible so that you can do searches faster. Whereas with an online transaction system, it's to write the data faster rather than doing searches. But an analytical system would be something that you would use Power BI with, or you might use multi-dimensional cubes to do analytics of data. And generally, online OLAP systems are going to be used for doing data that is going to be looking for historical trends and for features that will make the system be able to improve sales and those sorts of things. So transactional workloads have something called the ACID process. Okay, and so the ACID process allows us to track interactions as the interaction is working through the system, so that we don't lose any of the data that goes with it. So first of all, each transaction has autonomy, which means that each transaction is treated as a single unit which success completely or fails completely. So as an example, you go to the bank, right? Just once in my lifetime, I would love to be able to go to the bank and withdraw $1 million from my savings account, even if I didn't have $1 million in my savings account, and put it into my checking account and then spend it, and the bank would be none the wiser. Unfortunately, if that process of the withdrawal from the savings account fails, because unfortunately I don't have $1 million in the bank account, then the deposit into the checking account won't actually work, because it either works entirely together as one successful transaction, or it fails entirely together as an unsuccessful transaction. So each transaction has autonomy. Consistency. Every transaction is consistent because transactions can only take the data in the database from one valid state to another. Okay, so if we use the bank account example again, if I'm doing a transfer of money from my savings account to my checking account, I have to make sure that the transaction that is taking the money out of my savings account can actually be valid, right? And so the only valid state that the transaction can be is successful or failure, right? Successful, I've got money in the bank account to transfer the amount that I want to transfer, or it's unsuccessful because, sorry, it's empty. Right, so it just depends on what the transaction is. The next one is isolation. Concurrent transactions or concurrent execution transactions will leave the database in the same state. So what that's saying is that I could execute 2 or 3 transactions at the same time, but because each transaction is independent of each other, they don't have the ability to bash one another in the way. So if you've got 3 transactions executing and one of the 3 fails, it won't have a negative impact on the other 2 if there's nothing wrong with them. So the isolation that we have, the ability to isolate each of those transactions, makes it much more quick, because we can execute multiple tasks at the same time, and we will get through the data much quicker. And lastly, durability. So the last part of ACID is making sure that once a transaction has been committed, it stays committed, right? So there is an undo or reverse transaction capability that's built into the SQL language. And of course, sometimes we may need to reverse a transaction, but the system won't reverse the transaction unless it needs to, or unless I tell it to go and do it. because of the fact that it's durable, it's going to make that transaction, it's going to execute whatever that transaction was, and it's going to keep that execution unless I manually or automatically, based on a script or some other type of error checking, validates that the transaction should be rolled back or not committed. Okay, so this way we have a guarantee that everything is actually going to be stored into the database system as we intended it to. Now, with an analytical workload, there's no requirement for ACID. The reason why is because we're not writing individual transactions to that database. That database is basically an extraction of the data that lives in the transactional database. And so for this data, we're going to be using things like summaries. We're going to be looking for trends. We're going to be looking for business information. But this data does not update frequently, right? Whereas in a transactional system, you might write 1,000 or 5,000 transactions per second. If you're in a finance system, as an example, and you have all of your customers logging into your bank through online banking, you could have 1 million customers connected at any one given time, and that's 1 million transactions that have to occur, right? But in an analytical system, because it's not being accessed by that many people at that given time, in a normal business, you might have 15 people connecting to an analytical system. And because of that, there's no updated transactions that are being written to that database at any point in time. Any calculations or mathematics that you do against that data is done in real time and is not written back to the cube. The cube just has the raw data in it, and so you would store that other information in a different location. So analytical workloads are just typically going to be read-only, okay? Not much of a write, but read-only. And because of analytics, these again are based on snapshots of any point in time data. And so again, an example would be a monthly sales report, right? So at the end of any calendar month, you would upload the previous month's sales figures from the transactional system into the analytical system, and then you would do an analysis of that information. So that data will only replicate and update as required, and it's usually on a very rare basis, or not a very rare basis, but rarely. So next, we need to take a look at, where's my notes? The next thing we need to take a look at is the idea of data processing. Because of the fact that we have all of this data, okay, the data that we have is going to break down into two streams that we can actually convert this data to information that is usable by some user to do whatever it is that they're trying to do through a process, okay? So there are two sort of levels of data processing that we have. One is called batch processing, and one is called stream processing. So there is a bit of a difference between the two in the terms of how the data is actually processed. So the data processing, batch processing element, all of the input is collected into a group. And then once there's enough information in that group, whether it's based on the amount of data that's loaded into the group, or there's a timer in the system that says that this batch will execute every X amount of time, whatever is in that group gets processed as one job, okay? So the whole group is all processed at one single time. This is important when we're looking at large infrastructure systems or old mainframe systems, because any one transaction owns the processor of a system. So if you have a queue, first in, first out queue, a FIFO queue, whatever goes into that queue will obviously sit there until it's turn to actually process. So if you have an execution of a process that's going to take a very long time in terms of execution length, then everything that sits behind it is just going to wait there. And it's just sitting there and waiting and waiting and waiting. And the queue can get longer and longer and longer and longer because you may have a number of transactions that are going to execute in CPU time in a long period. By doing it as a batch, everything that's in that group even though they're still executed one at a time, they're all done together. And so the system will only take up as much time as required to have that batch execution completed, and then it'll generate the output for all of it, okay? Again, when you're working in shared systems like a mainframe or some on-premise database systems, running applications or running data resources as batches is very important. I'll give you an example. I was doing some training many years ago now, and I was teaching some people basic SQL query languaging. And it wasn't specifically to Microsoft or anything else. It was just straight fancy SQL. And the organization that I was doing it for was a multinational organization, and they were running their entire organization off of AS400 mainframes. And so the entire world of their organization in 75 different countries are all basically interconnected to this mainframe structure. And they all had their head office in Europe, and so everybody worked that way. So what happened is that going into the classroom, everybody has their mainframe sessions open, and I very specifically told them at the very start of the class that when we're doing the lab exercises, you must include as batch at the end of every execution. So if you were doing a select statement, or you're doing a write statement, or something of that nature, you needed to make sure that you included the as batch command. Otherwise, everybody's transaction would run independently. So one of the students, I don't know why he decided to do this, but he decided that he was going to make a copy of the global address book from the central repository to his file share, his file folder on the mainframe system. Well, the company's global address book was quite long. Several million addresses were in there. And so he forgot to put as batch at the end of it. And so when it got to his process, the system basically couldn't do anything else for anybody else in the world until his process finished. So needless to say, the director of IT came down to the classroom and he's like, "What are you guys doing in here?" And I'm like, "I'm just trying, I don't know." So we found out what the actual process was, and we killed it so that the system could come up and continue running. But the rest of the training that week, the IT people were so concerned that somebody might forget to put as batch that they actually built a separate mainframe overnight as a standalone mainframe AS400 system just for that classroom, so that it didn't potentially break the entire company, and so that the entire world wouldn't have to wait for this process to finish. So that's an example of why processing as a batch can be very useful and very helpful. Some terms that are important here: data scope. Okay, so a batch process, when we're looking at the scope of data, can process all of the data as a data set. And then stream processing that we have below typically only has access to the most recent data received or within a rolling time frame. So this example lasts 30 seconds. So when we're doing stream processing, each new piece of data is processed when it arrives. So in this case, input 1, system will upload it, will do its thing. Input 2, then the system will upload it and do its thing. So stream processing is the capability of having the system execute as arrives, but also has the ability to bring the system down and to basically not make it work very well. So the data scope is important. Also the data size. So if we have large amounts of data and we need to handle those large data efficiently, then batch processing is the preferred method. If, on the other hand, we're not using very large records, or there's very small information that's being written, then we would do more stream processing. And streaming in some ways is still batch work. It's just considered to be a micro batch, because the amount of overall data that we're going to be processing is considerably less than it would be in a normal batch. Obviously, the next one is performance. Latency has an importance in this part. So batch processing is typically a few hours, because with batch processing, you can schedule it. So you can specify that it's done after hours, depending upon the type of batch that you're executing. Whereas streaming is immediate, okay? And so because of that, there is going to potentially be latency that exists in the system of a few seconds or milliseconds or minutes, depending upon what it is. And then so, of course, latency is the enemy of efficiency, because if we have a latency in our system, then the system isn't efficient and we won't be able to process information as fast, and users tend to be grumpy when that happens. And analysis. Lastly, you typically use batch processing to perform complex analytics, and stream processing for using simple response functions, doing standard aggregations, things like calculations with rolling averages, individual easy CPU easy transactions. Batch transactions would be to do, let's say that I need to create a pivot table that has, 1 million records that I'm processing, and it's going to take 6 hours to process. Well, I'm not going to run that as a streamed activity. I'm going to run that as a batch process, just because it'll take less time to do it as a batch, and I can schedule it for after hours. So as part of managing this whole conglomeration of data and infrastructure and stuff, we have 3 different types of people that are very important to not only making the data useful, but making the systems usable. The first one is the database administrator, right? So obviously the database administrator is responsible for managing and doing the day-to-day infrastructure components and configuration of the system, right? So they're responsible for all the database management, building the servers, building the data files, doing the backup structures, doing offline backups, doing restores as required, those sorts of things. Implementing data security, big, very large, important role for the data administrator to make sure that the data is secured so that only the people who require it need access to it. And that includes the user, who actually gets access to it based on the application and the role of that user within that application and so on, as well as they are also responsible ultimately for maintaining performance. Now, if a DBA is really good at their job, they can actually use the tools in the system to automate a lot of the functionality that's there, to have what I refer to as proactive management versus reactive management. And if the database administrator does a good job of making sure that that a lot of the proactive capabilities of the system are configured properly, they don't really have to work that hard, right? They may have to fix a few things that pop up as an emergency here and there, but if they've got preventative maintenance turned on and set up properly within the system, they really don't have that difficult a job. It will be a really simple job for them to do. No, you probably don't want to hear that for people that are managers or database administrators, but that's the reality of it. Data engineers, data pipelines, and processes are their responsibility. So they're the ones that are going to actually architect and come up with things like database structure, how data is stored, how you're going to integrate that data with other storage systems, how you're going to prepare the data for analytics. So that would be the things like creating the data warehouse, creating the cubes, creating the data marts, those sorts of things, and parsing the data so that it can be processed further down the line, as well as preparing data for analytical processing, right? So not only just preparing it for the analytics component, but actually the processing components as well. So that's executing the batches, running specific types of jobs, and then executing queries that users will have. And then the third important one is the data analyst. So the data analyst's job is actually quite an important role. Sometimes the data analyst is the data engineer as well, but it depends on the size of the organization. But the data analyst is the one that's actually going to give you the information, right? So they provide insights into the data. They will use reporting tools such as Power BI to generate visualizations so that they can visualize the data, and so that they can take it to an individual and say, here, this is what your data looks like. A lot of times previously, you would take them an Excel report and say, here's your data, and it's just a whole table full of numbers, right, with no sort of analysis that's done with it to describe what the numbers mean. And so the data analyst's job is to take that data, make it meaningfully useful for people to actually understand it and read it and so on, and then be able to present that data to people. As an example, my nephew is a data analyst with a credit union back in Canada, and his job is basically every day to create Power BI reports for people at the organization. That's all he does. And he loves it. He actually has a degree in actuarial sciences. I hate math and he loves it, so I'm not quite sure how that works. But he loves doing these types of things, and he's very, very good at it. Common tools that we have. So as a database administrator, we will have, because we're going to be using the Azure platform to manage our data, we're going to be using the Azure Data Studio. So the Azure Data Studio is a graphical location. It's an interface that we have that's going to be used for managing on-premise as well as cloud-based data services. So if you have a SQL Server in the cloud and you have SQL Server on-prem, you can use the same Data Studio to manage it. That Data Studio will run locally on your desktop, and it runs on any operating system, Windows, Mac, or Linux, and gives you access to all of those systems. As well, that tool, that Azure Data Studio, will give you access to all of the different data platforms that exist in Azure. So it's not just Microsoft SQL Server, it's also Cosmos DB and any other data flavors that you might have for database systems running in your Azure tenant. Also, it will not just run the tool against SQL Server for Windows, as an example. It could also run SQL Server for Linux, right? So Microsoft SQL Server a couple of years ago has now started supporting deployments onto Linux, so you'll be able to manage that. Cosmos DB is a Linux-based system as well, and so you can use that tool to manage that, as well as any of the other tools that exist in the system. Good old SQL Server Management Studio, or SSMS. It's going to be the standard go-to, the typical graphical interface that you'll manage both your on-premise and cloud-based data services. Runs on Windows. It only runs on Windows, of course, because it's a Windows-based, although it will run on Linux as well, locally, and not in the cloud, but locally. And it gives you all of the standard administration tools that you require to do your database administration on a day-to-day basis. If you're using Azure Data or Azure SQL in the cloud, the only way that you'll be able to manage those databases and do the actual implementation, security, that sort of stuff, is through SQL Server Management Studio located on a desktop machine or a VM existing in the cloud. And that's how you would manage Azure SQL storage and Azure SQL. Again, the SQL Server runs as a service, so you don't actually have access to the physical SQL servers, but you will be able to manage the infrastructure that sits on top of that via SQL Server Management Studio. And for those of you that like the good old days of typing stuff from Unix and that sort of stuff, there's the Azure portal and CLI, client the standard character-based command prompt type of thing. The Azure portal and CLI allows you to connect to data sources and do things as a script. And so these are different management tools for management and provisioning of the data, of the Azure data structures in the Azure data platform, and allows for manual and automation of scripts using Resource Manager or command line interfaces. And it supports both Bash and PowerShell. So you'll be able to create those different types of scripts and run them remotely through the Azure portal and connecting to those data servers and data sources that exist in the cloud. The only thing is that, of course, you do need to make sure that you have sufficient permissions. So obviously, some people who are going to be administering SQL servers don't necessarily have Azure access. So you'll need to make sure that whoever is administering the system gives you sufficient rights to be able to execute those commands through the Azure portal. Some other tools, if we're doing data engineering, we've got tools such as the Azure Synapse Studio. This is another tool that's integrated to manage the Azure Synapse Analytics tool, and also uses the Azure Data Factory as well as the Azure Synapse app sets for SQL pools and Spark pools. So if you're using Synapse Studio to do high-level analytics and analysis of data, you'll be using the Synapse Studio to help you actually design those infrastructures and build out the capabilities of it. As well, also for data engineering, there is the SQL Management Studio, as well as the SQL Azure portal or the Azure portal and CLI. But primarily for data engineering, you're going to use the Synapse Studio to build out things like Hadoop data sources and those sorts of events as well. So the common tools that are going to be used by data analysts. So Power BI is sort of the de facto analysis tool that Microsoft has. It's quite a good tool. You use it to set up your visualizations, reports, dashboards, and those sorts of things. So this is the Microsoft data visualization tool. You can also create model and visualized data. So you could actually create online data sources and replicate data across them and then create visualizations from that. And the Power BI will directly connect to and work with the Azure Synapse assets, whether they're SQL pools or Spark pools that you've got on your system. There are a number of different tools, and if for those of you that have attended previous sessions that we've done on these Saturday seminars, you may remember that we did a session on the Power Platform. Actually, I think it was about 2 weeks ago that we did one on the Power Platform. And of course, Power BI is part of that Power Platform. But there are other tools that exist within that platform, including the Power Apps. So basically being able to create low-code developed environments for building custom apps, regardless of whether they're Canvas-based apps or they're model-driven apps that you can create. And these exist in what's referred to as the Dataverse, which allows for simple integration and interaction with existing data. Because we can create data in the Dataverse, and because we have this capability of creating these relational tables in the Dataverse, we can use Power BI to analyze and work with that data. Power Automate, obviously Power Automate is a way for us to do automation workflows between applications and services. And this will help to reduce the overall amount of effort that you would need to do repetitive business processes, such as data collection, decision approvals, those sorts of things. So, if you have an expense approval process, you can use Power Automate to work your way through that. Another thing that Power Automate is good at is taking a look at existing processes that you have in existing systems, whether they're on-premise or cloud-based systems, and it can record the processes that you execute, the steps specifically to execute a particular process. And then at the end of it, it can generate a Power Automate shell and will give you a workflow out of it. You can then customize that workflow to add specific things into it, but it does give you a very nice way of creating power automations and workflows from existing manual processes that you do in other systems. So if you have an older, let's say you have an older home-built, internal built, finance system where you process purchase orders and invoices and stuff, you can actually run Power Automate Desktop, and it will then do the recording of the tasks that you complete in that application. Once you've done and you've saved it, it will then generate the steps that execute within that application, so you can generate a Power Automate task that will go ahead and do that for you, especially if you're trying to do repetitive things over and over again. It's very good for that. Power BI, obviously we've discussed Power BI, but the last one is Power Virtual Agents, which allows you to create chatbots using a guided no-code graphical interface. And this is a way for you to be able to create these without the need for any data scientists or developers. Not that they'll want to hear that. But this allows you to create these bots that you can run online so that you can execute data that initiate communications and hopefully solve problems with customers and users as they need. So as I mentioned, the Power BI Desktop, that's the free tool that you can download from Microsoft. Anybody can use Power BI Desktop. You can create virtualized visualizations, you can create reports and dashboards and all the rest of it. The only limitation that Power BI Desktop has is that if you do not have a Power BI portal, which is what we'll talk about next, the only person who will actually be able to see anything that you create in Power BI Desktop is yourself, okay? Generally speaking, the goal of creating Power BI reports is not just used for self-consumption. It's for somebody else to be able to use it. And so you will need to then go through and have either the Power BI portal or a Power BI service, okay? So the Power BI portal is where you will actually go to on the web, on the internet. So you'll have a repository there that you can upload your virtualizations in, and those visualizations will get loaded onto dashboards. And then those dashboards can be made publicly accessible or internally accessible to users within the organization. And then at that point, they'll be able to actually be able to view and work with the data. When we're looking at the Power BI portal or the Power BI service, it does give us some limited authoring capabilities of Power BI reports. However, the amount of capabilities that the Power BI portal has to generate a report is very, very limited. The Power BI desktop tool is the tool that you'll use to actually build all of the things that you need, visualizations and reports, and then they will get uploaded to the portal. But that is where you will author your Power BI dashboards, right? And so the dashboards are just a combination of reports and visualizations that you've created in the Power BI desktop, and those are created and managed through the portal or through the service, as well as this is how you're going to share all of the reports and data sets that you've generated in the system. And then lastly is the Power BI report builder. This is the data visualization tool. If you need to create page-native reports, this is the tool you're going to use. In some ways, this replaces SSRS or SQL Server Reporting Studio and generates the reports that way, and does both model and visual page-native reports. So it could be model reports or just generally tables with data in it, or visualized reports where you actually have graphs, charts, and so forth. So to identify relational database use cases. So what are some of the ways or the places that we will use relational databases? Well, as a day-to-day database user, you will be doing things like entering data into a system, making sales, processing requests, processing purchases, those sorts of some day-to-day data tasks. Some other things that we can use because we're using the relational database as a way to store the information in the online system. We're going to be using it for things like IoT. Okay, so when we're doing Internet of Things, we will use a lot of that data and store that data for analysis later. So as an example, you might want to look at the historical trends of runway icing values. So you'd have an IoT sensor that runs in the ground underneath the runways and deep into the ground, and you'll record all that information, and that will get recorded into a relational database that will later get used in an analytical database to find out, okay, well, how often do we hit -30? How often do we hit +10 in February? How much chemical did we use? What chemical format did we use? How long did it take to de-ice the runway, and all that sort of information. So you can record all of that using IoT devices. Obviously, online transactional processing, systems for transactional updates such as sales or marketing, those sorts of things, as well as using relational databases for data warehouses. Okay, now data warehouses are generally, as I referred to before, as denormalized data. But because it has a large amount of data and it's very structured, that data, and that data could be generated from many sources, it's going to use a relational database structure, even though that database structure is designed for a high volume, high performance query engine. And so it's going to allow us to make sure that the data is stored and organized properly. The first thing that you'll notice when we look at a relational table or relational database is that it uses a table structure, okay? So the main characteristics of relational databases are that the data is stored in a table, so it's just like an internal, Microsoft Excel spreadsheet, but it's inside of a database file. The table always consists of rows and columns. All rows will have the same, or all of the table will contain the same number of rows. Sorry, let me try that again. All the rows have the same number of columns. That's probably the better way to put it. And each column is defined by a data type. So how do we determine how we're going to store data in the system? Well, there's a number of ways. So first and foremost, if I'm going to be putting data in, let's just say I'm creating this table that we see on the screen, customers. Very simple table, holds a very little bit of information, basically 3 pieces of information. It's going to generate a customer ID. It's going to have the last name or the customer's name, full name, and the customer's phone number, right? So we can do a number of things. So as an example, the customer ID would generally be an integer because it's a limited number of numbers, or it's a limited number of values. In this case, it's a 3-digit code. And an integer would be a very simple way to store that number. There's not going to be any decimals. There's not going to be any duplicates. It's just going to be a single integer number for every customer. For the customer name, we would create probably a var text field. And the reason that we would use a var is because we don't know how long a person's name is going to be. So we will create a table column that has a data type of var, so allows it to have variable length. It could have 2 characters, it could have 50 characters. So it's just whatever the person's name is. And then the customer phone one could be an integer, it could be a float, it could be a whole number. It just depends on how you store the number. In this particular case, it may also be a text field, because you'll notice that the text format is XXX dash. Of course, dashes are not numerical numbers, numerical characters. So this might also be a text field as well. Now, each of these tables have what is referred to as a primary key. So in this particular table, the primary key field is the customer ID. So a primary key field has 2 unique characteristics. One, it is always an integer. Always, always, always going to be an integer. Second of all, no 2 rows can share the same primary key value. So because of the fact that we set customer ID up as a primary key, no 2 customers can have customer ID 104. That's just not possible, okay? Because the primary key has to be unique in the values that are existing in that key column. So in this case, the customer IDs will always be unique. And generally speaking, they will also be sequential. So in this particular case, the numbers will get auto-generated. They will not be user-entered, okay? You cannot have a primary key field where you enter values in manually. It's always auto-generated. So something like a customer number, or a purchase order number, or a purchase requisition number, or a RMA number, or something of that nature that is used to identify unique individual values that have to be in each of those rows. Is how you would define it. Now, so that would be what's considered the parent table, or the primary table. In this case, again, the column is the customer ID. I might have another table that exists that has other pieces of information in it. Let's say the customer's address in it, but I am going to have 2 columns in there that identify individual information uniquely. First of all, I may have another primary key ID column on that table, but I will also have, most likely, a foreign key field on there that references the primary key field on another table. So in this particular example, let's say that I have the customers table and I have an address table, okay? And the address table has 3 columns in it. It has a street address, 4 columns. It has street number, it has address, so street name, it has city, and it has state. Okay, so and I want to put in as an example Zenis Omar's address, right? So when I go to enter Zenis's information, even though the form that I'll be using on the screen has all of the fields to contain that information to it, when it gets written to the database, it gets separated out. So the primary field on customers gives Zenis a customer ID of 104. That's his identifying number. So he'll always be able to be found in the system as number 104. No matter where you look, he's always going to be 104. So when the data gets written, so 104 puts the customer's name in there and the customer phone number in the customers table, but it then is going to write the address information to the address table. And so for us to be able to understand without having really odd numbers of data in the address table, it uses a foreign key field that references the primary key field of the customers table. So the foreign key field will have ID number 104, which is Zenus, and it will put Zenus's address information into that table. And so if I go to look up the information, that is how the system knows that this number, 104, references this individual Zenus. And so it'll display that information from any table in the system that has any sort of reference back to ID number 104 and give me all that information. Could be his postal code, could be his order number, could be his gender, could be all sorts of different things. And that will be a way that we can reference the information. So in a relational database, we have foreign and primary key relationships. That's the whole point of a relational database, is that we have these relationships built in. Another thing that exists within the system is this idea of entities. Okay, now the definition here is that an entity is representation of an item which can be physically, such as a customer or product, or virtual, such as an order. Okay, so an example is a customer a customer can place an order for a product. So that's an entity, right? An entity is always a noun: product, user, name, customer, that sort of thing. So entities are connected by relations, enabling the interaction. So in the example that I just gave you in the previous example, where the customer table and the address table, that relationship between them is considered to be an entity. So Zenus is an entity, right? Brent Dawson, if you put Brent Dawson in there, he'd be number 107. He is an entity because he has that relational information that exists amongst all of the different tables in the system. And so that's how we actually get the information all existing around all of the other environments. Now, this is the boring part. So if you've not fallen asleep up until this part, you're doing good. So prepare for your snooze fest for the next few minutes. Normalization is the process of stripping down the amount of data that is stored in individual tables. So you're probably thinking to yourself, why would I want to do this? Why wouldn't I just have one great big table that has all the information in it? It's all in one place. It's easy to find. Bingo, right? Well, not really. The reason for that is that when we start having really large tables, it gets very difficult to find information for it when we go to look for stuff, right? It's like, I go and buy stuff in July for Christmas presents and I put it in the closet. And then come Christmas time when I'm going out to buy presents again, I've forgotten I bought it or I forgot where I put it. It's like, oh, I bought that. Where did I put it? And then I gotta go find it, right? And then I gotta tear my house apart to figure out where exactly I put this thing so that I can give it to the person I was intending it to give to. Okay, so that's not a very efficient way of having to do stuff. Also, with a denormalized database, we tend to have to look at every single record in the table when we're trying to find an individual piece of information. Again, very time consuming, very processor heavy, and it's not very efficient. So we do normalization, okay? And so normalization takes data and breaks it down into smaller pieces. So in a way, it creates a bigger amount of tables in the database, but when we have a normalized database, it allows us to write the data to the system faster, okay? Because it doesn't have to write the data all in one place. You can put it into the appropriate places, and it improves the quality and the speed of the system. So data normalization is done to accomplish three things. One, reduce storage. I know it sounds silly. It's like, well, if we're creating multiple tables, then how are we reducing storage? Overall, we are, because the total number of bytes required to store that information is reduced unless we put them compared to putting it in a single table. It has helped there to avoid data duplication, because in a single table, it is possible that we would have somebody who lives at the same address, right? You might have two people that are buying something on an online store, and they live at the same address, they have the same phone number, they have the same postal code, all the rest of it. Why do I need to keep a copy of that information in the system over and over and over again, right? I only really need it once, and I just have to reference it. So the other one, last one, is to improve data quality, okay? So there are three different levels of normalization that we have in relational databases. The first one is first normal form, or 1NF. 1NF specifies that each cell should only contain one value. Makes sense, right? I don't want to put multiple pieces of information in one cell. That makes no sense. So I just want to make sure that each cell contains one piece of information. Customer number, customer name, customer phone. Each one of those have one piece of information. So that's 1NF. The next one is second NF, or second normal form, or 2NF. And that states that every non-key column depends upon the whole key. So what this is saying is that the customer name and customer phone needs to have the customer ID there. Otherwise, it makes no sense as to why that data is there. Can't use it, can't see it, can't report against it, can't search for it, useless. So it has to relate entirely to the key field that is on the table, which is, in this case, customer ID. The last one is third normal form, or 3NF. In third normal form, columns do not depend on any non-key column. So the phone number doesn't require customer name. Customer name doesn't rely on there being a phone number, right? They don't relate to each other. They don't rely that each other has to be there. They only have to make sure that they're representative of the primary key field, in this case, again, customer ID, right? So you'll notice here that customers and orders, right, there's no relationship to them. How do I know that the order AD0100 is for customer name, customer phone? Well, I've duplicated that information. Why do I need to do that? Instead of putting customer name and customer phone, I create an order ID column, which is the primary key field for that table, because it's an independent integer and it's unique. It's not going to be duplicated. And I create one other column in that table called customer ID, which is a foreign key field that references customer ID in the customers table. I've reduced the amount of data that I've had to write in the table because I'm not duplicating the customer name and the phone number in multiple locations. It's already existing somewhere, so why do I need to do it again? Okay, so the whole point of this is to just, again, even though I may have more tables in the system, I've actually reduced the amount of data that I've had to write by half because I've created one field on another table instead of having 3 or 4 or 5 or 6. So it just makes it speed up and makes it easier to use. So here we've got the relations. Sorry. So in this database, this is normalized, right? So here we've got our primary key and foreign key relationships. This defines the relationship. So the primary key field is always going to be the first column, by the way. In this case, it's when we're doing it physically, it's going to be the left-hand column. It's always going to be the first column. So we've got customer ID related to both tables. So in the parent table, it's the primary key, and the secondary table, it's the foreign key. And we've got reduced amount of information there. So instead of having 2 columns that have variable length text in it, and 1 column that has an integer in it, we now have 3 columns that have integers. Integers are 2K in size, much smaller than a text field, than a variable text field. Also in this scheme, we have no duplication of data, which falls under the third normal form process, right? Other than the key values in third normal form. And the data is retrieved by joining tables together in a query. So we would say that select customer ID where customer ID from customers and customer ID from orders equals 100. And it'll pull the data out and give me the responses that show the information for those 2 systems. Indexes. So indexes in a relational database make life even better because it speeds up the process of being able to retrieve the information. So think about an index this way. I'm going over to the filing cabinet. Okay, so I want to find the record for Brent Dawson. So Brent is a B, right? B comes after A. So I'm going to go over to the filing cabinet, and hopefully on the filing cabinet, it's labeled each of the cabinet drawers with a label, but let's say that there's nothing, right? So everything that's in the drawers is in alphabetical order, but or actually, sorry, let's take that back. So the first example, they're not in alphabetical order. The files are just put in as they're entered into the system. So the first record could be George. The second one could be Dennis. The third one could be Terrence, and then it gets to Brent, right? But the only way that I'm going to know that is by going through each record, each file folder in that filing cabinet. And I don't mean that we would stop when we get to Brent, because what if there's 3 Brents? What if there's 4 Brents? What if there's a half a dozen? I need to find all of them. So I need to go through every record in each of the drawers of the filing cabinet until I find all of that instance of the record that I'm looking for. Well, if there's 10,000 records in that filing cabinet, that's not very efficient. And I'd have to do that every single time I'm trying to find some information. Useless, right? Totally useless, doesn't make any sense, not efficient at all, right? So how do I solve that problem? Well, I solve that problem by creating an index. And an index does 3 things. 1, it optimizes the search query for fastest or faster data retrieval. Generally, when we implement an index, it does 2 things. A, it puts the data in sequential order. So if I'm putting in data based on the letters of the alphabet, it's going to put them in alphabetical order. That in and of itself will make life a whole lot easier for when you're trying to find information, because you're doing, basically you're looking at it and going, oh, okay, I need to find B. B is greater than A, so I'm going to go to the B column. Oh, look, there's B. Okay, so B, R. Well, R is greater than A, and R is greater than B, and R is greater than C, and so on and so on. But even though it's looking at all those letters, it's still faster than having to look at every single record in the database. The second thing is it reduces the amount of data pages that need to be read and retrieved into the SQL statement. So as I just said, when it's looking for information, it knows that B is greater than A. So I can skip all the pages in the table that have A in them as the first letter, and I can go to the B's. Yay! So I've cut half my time out right now. And so if I'm looking for Brent Dawson, I know that there's got to be, all the Brent Dawsons are going to be in the B's. So they're going to be within this starting row and this ending row. And so that's the only area that I have to actually search. And then lastly, the data is retrieved by joining tables together in a query, as mentioned before, where I'm searching for one record and then I join it to another table with the same record, and it's going to retrieve those values that match. Okay. So the indexes that we have are very useful. Makes life a whole lot easier for finding information and being able to retrieve that information out of the system. Okay, views. A view is a way for me to take data that's in a table and create a virtual table of the result sets. So when I have data in the existing system, I might have 3 or 4 or 5 tables. What a view does is that it doesn't actually contain any data. It's a temporary table that contains the result sets of a query that is then displayed to the end user as a query result. Okay, so views are created to simplify a query, and they combine relational data into a single view for the user to be able to access the data and use it for some task that they need to complete with, but it doesn't do anything other than that, right? So all the view does is it takes the result sets from all of the queries, parcels them up into a readable view for the end user, and that's what they get to actually see when the results are completed. There's no data in the view. It's actually just a temporary table. It's destroyed at the end of the view execution, and then all the data goes away, and it recreates that view the next time the data is executed or the view is executed. All right, so Leela, we're going to take a short 5 or 6 minute break here, and everybody catch their breath, and we'll be back in about 5 minutes.
Thank you so much. Okay, so I'm going to go ahead and set a timer for 5 minutes. But while we're taking that break, for those of you who are still paying attention, while we're taking that break, we're going to go ahead. It's a great time to grab a drink, stretch your legs really quick. But also during this break, we want to invite you to participate in a quick poll to help us find out how many people might be interested in some additional training that we offer. So if you can go ahead and just click on that real quick and, make your selection before you go stretch your legs or once you get back. We'd really appreciate that. Okay, that is about 5 minutes. Are you back with us, Brent?
I am.
Wonderful. Thank you, everyone, for participating in that poll. We had about 90% participation in that, which is awesome. So let's go ahead and get back to it.
Okay, so the next thing we're going to take a look at is the idea of a non-relational database. So to this point, we've talked about relational systems and the way that relational data is stored in a table and how it uses relationships and normalization to store the data in the system. Now we're going to take a look at non-relational database systems. So non-relational database systems are a much different animal in the way that data is stored in the tables. First of all, non-relational databases have collections. They don't actually have relationships in them. So multiple entities in the same collection or container with different fields. So here you'll see customer number 1 has an ID of 1, right? So that makes them unique. So that's their name, their telephone number, all that sort of stuff. But you'll notice that customer 2, which also has a unique ID of 2, has a title, a name, has a home phone number and a mobile number, not a business number, and an address, right? But it also has multiple addresses in the UK and US. And the first person has a cell phone number, even though it's also a mobile number. So you'll see how it's just kind of a free-for-all. You put the data in and it just goes to town and stores all the data. Also, a non-relational collection has different non-tabular schemas, as well as are often defined by different labels, which each field in the name represents. So in this case, cell or mobile or home or business or whatever that we define the fields in that table to be. Oops. My mouse is in the right spot. So how to identify non-relational databases and sort of a use case for why I would want to use a non-relational database. So IoT, we mentioned earlier on that IoT can be used with relational databases, but generally speaking, because of the amount of data that is being collected from an IoT or a telematics type of device, it's going to be frequent large bursts of data and large bursts of activity. Those data are better off to be put into a semi-structured or an unstructured data and requires a lot less or more real-time processing. And so we would probably want to put it in a non-relational database after that. The next one is things like retail and marketing. Okay, so some things like globally distributed data, document storage, those sorts of things. Sometimes those will be put into non-relational databases. As well, some of your financial tools that you'll use on the internet are in non-relational databases, mostly because, again, there has to be a high level of speed available to those transactions. And so using a non-relational database can be more efficient at times rather than using a relational one. Gaming, almost entirely the online gaming industry uses non-relational databases, right? For things like social media interaction, leaderboards, low latency applications, those sorts of things. And lastly, a lot of the web and mobile analytics, so things like click analytics, application for bots, those sorts of things, those tend to also use non-relational databases as well for their data storage. The types of non-relational data that is possible, there's a lot of different types of data that we can store, and there's a lot of different systems that can store it. But when we're looking at non-relational data, it's also going to be referred to as semi-structured data. So it's not quite as structured as a relational database. It's not normalized. It's not tailored specifically for tables. It's just sort of semi-structured because there is a little bit of structure in it. The first one is a JSON document. JSON documents are enclosed in curly brackets, and each field has a name, which is its label, followed by a colon, and then the value of the field. The fields will contain the simple values or sub-documents, each starting and ending with curly brackets themselves. And then fields can also have multiple values held as an array and surrounded with square brackets. Okay, so that's the idea of a JSON document. Avro, which is another semi-structured non-relational data type, is a row-based format and it's created by Apache. So if you've heard of Apache web servers, which is Linux-based systems, each record contains a header that describes the structure of the data in the record. This header is stored as JSON. Okay, so it combines JSON into its structure. The data is stored as binary information, and so it takes data and converts it to a binary number. And an application uses the information in the header to parse all of the binary data in the body and extract the fields that it exists and contains. And Avro is a very good format for compressing data and minimizing storage and network bandwidth requirements. So Avro is like WinZip or WinRAR. I remember back when I was in university 30 years ago, we were tasked in my software engineering class to create a file compression tool. So much like, WinZip or any of that sort of stuff. But basically, we were doing a zip file, and I was really good at taking all of the data out and compressing the file, but I had a really difficult time making the data go back in. So I got half of it working, in the sense that I could get the compression part, but I could never get it to decompress, which obviously defeats the purpose. It's great, so I've got all these compressed files, and I'm saving all of this information, but I could never access it again, which is rather difficult. The next one is ORC or ORC, which stands for Optimized Row Columnar Format. And this organizes data into columns rather than rows. And it was developed by Hortonworks for optimizing read and write operations in Apache. Apache Hive is a data warehouse system that was built by Apache and supports fast data summarizations and querying of large data and data sets. And last is Parquet. This is another columnar data format. It was created by Cloudera and Twitter. And Parquet file contains row groups and all of the data. So if you go to your Twitter feed, all of that data that's in your Twitter feed is all unstructured data using the Parquet data format. So unstructured data, again, non-relational data tends to be non-structured. And it does not, so unstructured data does not naturally contain fields. So it doesn't have, like a column and a row and that sort of stuff. So things that would not necessarily contain fields would be things like videos, audio, media streams, documents, those sorts of things, right? Because there's no structure to them. They're just video files. They're they can have metadata that would describe the file, and that could theoretically be used as structured data. But the content or the file type itself does not contain fields in it. It's just a file. It's also often used to extract data and categorize or identify structures. Okay, and so again, so the metadata would be used as a structure for it, but the actual data itself is not structured. And lastly, unstructured data tends to be used in combination with machine learning or cognitive services in a way to extract data by using things like text analytics, so looking at text and figuring out the text speak and pulling data out of that. Also by using what's called sentiment analysis. So in Azure machine learning, there's something called sentiment analysis, which uses a cognitive API to determine the sentiment of a person's comments and make sure that they're happy or sad or grumpy or whatever it is. And also vision APIs, which is for video and visioning tools. So those are some of the common reasons that we would use unstructured data in the systems. So, relational databases, SQL, Oracle, DB2, those are great tools and they do really, really good work. But because of the way the world works now with a lot of analysis and large amounts of data stores and so on, unstructured data and non-relational data is also very efficient and very usable. Next, we're going to take a look at NoSQL, okay, which really sounds quite humorous. Well, if it's not SQL, then why are we calling it NoSQL? So it's basically, it describes non-relational database, okay? So there are key value stores. It has a document storage. So the key value store, each data item is a key, has two elements, a key and a value. Oh, I think I hear somebody else's volume is still on there.
Oh,
The key,
that was me.
yeah,
I'm sorry.
no worries. The key uniquely identifies the item and the value that holds the data for the item. Okay. It also has a document, so it's document-based, meaning that it represents the opposite end of the NoSQL spectrum from a key value store, in that each document has a unique ID, but the fields in the documents are transparent to the database management system. So the database doesn't care what's in those fields. It's just usable by the end user. And also then we have a column family database, which organizes data into rows and columns. So examples of structure include ORC and Parquet from previous example. And this is a way to describe units. And then graph databases. And we're going to take a look at a graph database here in a second. But a graph database is basically a visualization of a data store. So the graph database, this stores entities and information around relationships. Okay, so it's sort of like a relational database, but it's that it uses three entities that have some sort of relationship to each other. Okay, and so with this type of information, so we've got a database that stores two types of information: the node that you can think of as the instance of an entity, okay, and the edges, which specify the relationships between nodes. So here we've got an employee whose name is Sarah, and she works in a department which is called head office, and we have an employee whose name is Alec, who reports to Sarah, and we have an employee Anissa who reports to Sarah, and so forth. And so you can see by the arrows, the directions that the data flows in this graph database. And it enables applications to perform queries traversing a network of nodes and edges. This is also the same sort of structure that you have in what's referred to as a binary tree, where you have a leaf record and then child records that exist below it with some sort of relationship. So some examples of where we would use a graph database, or some business requirements, where we have, as an example, an OLTP system that has an app associated to it with high correlated data. So there's high correlations of information and data that exists between two different parts of the system. Easy updates to single or many objects. So here we've got information that is stored in a number of different places, but we want to be able to make the updates to those pieces of information as quickly and efficiently as possible. So as an example, if we are no longer having Sarah as the person who is going to be the manager of Alec and Anissa, then we need to be able to make a change so that it's easy to change the reports to for those records, right? So if Sarah leaves the company, then obviously Sarah isn't going to report to Max anymore, and so we need to change that as well. So or Max is not going to report to her, so we need to change that as well. So let's say Max now becomes the manager. So we need to slot the arrows in such a way so that everything is easily transferable from Sarah to Max. And this process has got to be easy and simple so that we can actually have the data transfer quickly. Another example or another business requirement is flexible data modeling. Again, as long as the data is flexible in the sense that we can edit it, we can update it, we can delete it, then we will fall under the standards for a graph database. If that information is not easily modeled, then it's not going to fit under the model for a graph database. The next one is data requirements that evolve, right? So no matter how hard as a data analyst or a data architect that we try to make sure that the system is stable and doesn't change, it's not always going to work that way, okay? And so we need to be able to have a system that will let the data structures that we have, the data formats that we have, evolve as the system changes and as the system matures. And so this graph database structure will allow us to have that evolution of the system without having to recompile and reconfigure the database every time. We could just modify it slightly. And lastly, it's a hierarchical data structure. And obviously from this graph that you can see on the right-hand side, it is hierarchical because we have different layers with arrows pointing in different directions. And so we have a hierarchy there that specifies who does what and who reports to who and who works for which department and so on. So data has a journey, right? Data just doesn't exist. It doesn't miraculously appear out of the atmosphere and say, oh, hey, I'm here, and wait, let's go. So data has a journey. First of all, data needs to be ingested, right? So ingestion is the process of reporting or importing data, which might come in the form of a stream or a batch or something else, but it's going to be put into a database, right? And it's the process of obtaining and importing all of that data for immediate use or storage for later use, but it's going to be put into a database. The next layer is data processing. Now, data processing takes the data in whatever form it comes in, i.e. its raw form, cleans it, also known as transforms it, and then converts it into a more meaningful format, okay? So there are two processes that are part of the data processing execution that allows us to ultimately get to that point. The first one is called ETL, or extract, transform, and load. When we use ETL, the data is retrieved and transformed before being saved, okay? So here we've extracted the data, we transform it, and then we load it into the system. So when we're doing extraction ETL, so if we extract the data from a data source, let's say that the data source uses yes, no fields as a data type. Okay, so actually Microsoft Access. Microsoft Access has a data type called yes, no. SQL Server does not have a data type called yes, no. They have a data type called binary, or bit rather. So bit is 0 or 1. 0 off, 1 is on, right? So 0 is no, 1 is yes. Okay, straightforward. But we can't just take the data from Access and pop it into SQL Server because the data types don't match. So what we need to do is that we need to transform that data before we write it to the database that we're putting it to. So as we're extracting the data out of the Access database, we transform the data type. So any of the records that have a yes, no data type to it will get converted to bit data type, and those that have records of yes will be 1, and those that have records of no will be 0, and those will then get written into the SQL database. Straightforward, very easy, okay? So when we do the extract, transform, and load steps, these are performed in a continuous pipeline, one operation, and it's suitable for systems that only require simple models with a very little bit of dependency between the items. Okay, so it's generally going to be quite a simple process to do the ETL, the transformation from the original system to the destination. The second one is called ELT, which is extract, load, and transform. In this process, right, the engine can take the iterative approach, meaning that it's going to retrieve and process the data from storage before writing the transformed data and models back to storage. And so here, the extract, load, and transform is more suitable for constructing complex models that depend on multiple items in the database, often using periodic batch processing. So here, again, so if it's much more complicated and there's a lot more work that has to be completed, then we're going to be extracting, loading, and transforming the data, and then putting it basically back into the system again. And then the last thing that we will do as part of the journey of the data is all of the visualizations that we're going to generate from it. So again, using Power BI, we'll create graphical representations of the information and the data. And so we will do that either by creating queries that will generate reports or by creating visualizations. Those visualizations, of course, will then give us the capability to interpret the data that we've got and be able to see it and actually understand it. Because if I was to give the average person a report of columns and rows of numbers, chances are most of them would just look at it and their eyes would glaze over and not understand what I'm actually telling them. So having pictures and visualizations is a much better way of doing it. So the last one, as we mentioned, is the data visualization piece. And data visualizations is ultimately reporting, which is the process of organizing all the data into informational summaries to see how different areas of an organization are performing generally. And reporting shows you what has happened, while analysis focuses on explaining why it happened and what you can do about it. Okay, so obviously reporting gives you a couple of different things. Business intelligence, right, is part of this. So business intelligence refers to technologies, applications, and practices for the collection, integration, analysis, and presentation of business information. And this business information provides historical, current, and predictive views of business operations, most often using data that has been gathered into a data warehouse, and then occasionally working from live operational data as well. But generally speaking, business intelligence is going to be done from a data warehouse that is partly data marts, data cubes, the paring down of the amount of information that you're going to execute against a specific type of report. And then the last one is the data visualization. And this is the graphical representation of the information and the data that you got from the previous two steps, the reporting and the business intelligence. By using the visual elements such as charts and graphs and maps and all those sorts of fun things, data visualization tools will give you accessible ways to spot and understand trends, take a look at outliers, as well as performs and patterns that exist within the data. So you can take a look at it and go, why did we go down in sales? Oh, okay, because it was the Christmas break, and people don't buy stuff while they're on Christmas break because they're not at work. So that's why. And then we see a spike again in January when people come back to work. So as far as data analytics is concerned, some of the data that we have allows us to use different tools to work with that data. And so there's a few things that we need to take a look at when we're talking about analytics in particular, and there's 5 different areas that we need to focus on. There's descriptive analytics. Okay, so in the world of analytics, everything is evolving from the typical descriptive analytics, which is it's all about, to what is happening in my business, right? So it's actually sort of forming that standard English question, like, what's my business doing today? Right? Why am I making money? Am I losing money? That sort of stuff, right? So very descriptive. Diagnostic analytics. This is where we have data insights that provide descriptive analytics, or that are provided by descriptive analytics, and then are needed to provide the answer to the next question, which is, why is this happening to my business? Which is often referred to analyzing root causes or diagnostic analysis, right? So I need to take a look at and figure out, why is this happening, and I can do diagnostic analysis against it. Both descriptive and diagnostic analytics is seen as a workload which is primarily providing a reactive response from what is happening, why is it happening, to what am I going to do about it, right? Like, okay, this is now on my shoulders. What am I going to do about this to make it work? So that's the first two. The third one is predictive analytics. So by building out predictive patterns on top of your data, and utilizing the data findings from descriptive, diagnostic, and predictive data, you will be able to identify what is based on what is based on what you get from the descriptive and diagnostic analytics, and then use to find answers to the questions of what is likely to happen in the future based on previous trends and patterns, right? So you're trying to predict the future, which obviously is quite difficult. It's like, trying to predict the weather. You don't like the weather, just look out the window. But predictive analytics is a way for you to try and see if the system will be able to, to be able to tell you what you need to do to make the system run better, to make your environments or your individual organization run better. The next one is prescriptive analytics. So prescriptive analytics are techniques used to provide a predictive insight into the data. And generally, it's going to be commonly introduced by building up machine learning models. And what these machine learning models will do is predict trends and give the answers to the very answers or to the very specific questions that you want to get answers to. So when you get the findings from descriptive diagnostic and predictive analytics, like what's happened, the root cause behind that, and what might happen in future, the prescriptive model utilizes those answers to help you answer the question, what do I do to determine the best course of action to choose to bypass or eliminate future issues, right? So it's going to give me a prescription to figure out how I can make this work best. The last one is cognitive analytics. So cognitive analytics combines a number of intelligence and different intelligent technologies, such as artificial intelligence and machine learning algorithms, deep learning algorithms, those sorts of things, to try and apply human brain-like intelligence to perform specific tasks. So this is basically the type of analytics that is inspired by how the human brain will process information, draw conclusions, and then use your standard instincts and experience to learn to understand, not only in words in a text file or what you're speaking, but also to the full context of what is being written or spoken in the system. And so it's going to use cognitive analysis to try and figure out what it is that you're actually saying, and then give you a result based on that analysis of that information. And so that's hopefully going to be able to provide you good value in terms of being able to predict and make your organization run better. Okay, so we've got about 4 slides left here to go, so we're pretty close to the end of the presentation. Azure services for the modern data warehouse. So I know we've talked a lot about SQL databases and NoSQL and relational and non-relational databases and all that stuff. We haven't really talked much about the Azure tools yet, so let's focus on those for the next few minutes. So the Azure Data Factory is one of the data tools that's there, and we've sort of talked about that, but this is a service that can ingest large amounts of data in its raw form, unorganized data from relational and non-relational systems, and then convert that data into meaningful information. So the tool provides scalable as well as programmable ingestion engines so that you can use to implement complex hybrid extraction, transformation, and load or ETL systems, as well as ELT systems and data integration projects. So the tool allows you to basically take any data you want and make it work. An Azure data lake, or as I usually generally refer to them as data swamps, because in most organizations they have so much data that and they have no idea where it is or what it does or what it looks like. So it's not really an organized lake; it's more of a swamp. But a data lake is a collection of analytics and storage services that you use to combine to implement a big data solution. And it generally is made up of 3 main elements: the data lake store, so the actual data store itself, the data lake analytics, and then a tool called Azure HD Insight, which we'll talk about here in a minute. The next thing is something called Azure Databricks. This is an analytics platform that's optimized for Azure, and it's designed with the founders of the Apache Sparks system. This is integrated into Azure to provide basically one-click setup. It does streamlined workflows and is an interactive workspace to enable collaboration between data scientists, data engineers, and business analysts to be able to actually execute all that data. The HD Insight is a managed analytics service that exists in Azure Cloud. and it's based on the Apache Hadoop process. And this is a collection of open source tools, different utilities that help to enable run processing tasks over large amounts of data. As well, HD Insight uses a clustered model similar to that of Synapse Analytics, which we'll talk about in a second. And generally, this stores data in the data lake itself. And you can use the HD Insight to analyze data using frameworks such as the Hadoop mapping tool, Apache Spark, Apache Hive, and a number of other tools that are open source tools as well. And then lastly is the Azure Synapse Analytics. This is generalized analytics services. And again, this is used for reading data from many sources, producing data that is going to be either relational or non-relational, structured or non-structured. And then from there, you can create various analysis models and then save the results after you've done your analytics. So Azure Data Factory, as I mentioned previously, is a service that will ingest large amounts of information. Generally, it's going to be unorganized data from either relational and non-relational systems, and then convert the data into information. And it will perform both ETL and ELT transformations, as well as data integration management projects as well. And in this tool, you create and schedule data-driven workflows, which are called pipelines. And those pipelines will then ingest data from the disparate data source, and then used as a way to collect its information. So an example is like a gaming company stores all the information by that company. And then you could build complex ETL processes and then do transformations of the data visually with data flows or by using compute services like HD Insights or Azure Databricks, SQL databases, that sort of stuff. And then once you've done that, you can publish the transformed data to the Synapse Analytics, and then that will then allow you to do business intelligence applications to consume that data. So really, the data factory is just there to get the data ready to be used by other applications and other tools. The the data storage is just the repository for the data. Okay, as we mentioned previously, it organizes all the files into directories and subdirectories to organize it. It uses blob storage to mimic a directory structure. And it's a way for you to do granular security over data, actually specifying who can access it using ACLs or access control lists. And it's compatible to using things like Hadoop, a distributed file system, or HDFS, where you have highly flexible and programmable analytics services, as well as file storage and file access systems as well. So it's a combination of different storage types and different access types. Databricks, again, is an analytics platform that's optimized for SQL, or for Azure, sorry. And it's based on the Apache Spark system. And it uses a number of open source tools and collaborations to give you the way to analyze and process as well as stream the data that you generated. And there is a direct integration for services like Power BI, where you can then generate your data sets and display them as dashboards. Analysis services, again, builds on the tabular models to support online analytical processing, or OLAP queries, combines data from multiple sources, and it could be any one of those types of things. It could be data lake, Cosmo databases, and any other type of data access that you have. And then lastly is the Azure HD Insights. As we mentioned previously, Azure HD Insights is a big data processing service. It looks, you can always recognize it because it has the yellow elephant icon. And so you can always know that you're doing and using Hadoop for that. And so it's a managed analytics service that's in the cloud based on Apache Hadoop, as I mentioned previously. And it's just another set of open source tools that allow you to run processing tasks over large amounts of data. And as you can see here, it uses a number of different tools, so things like data lakes and databases, blob storage, could be using sensors and devices. It can create graphs and reports using graphical databases, It has Databricks notebooks connected to it. It can be using Spark libraries. So it pretty much is sort of like the be-all and end-all tool that will allow you to use any number of languages to store and dispose of data in that system. Okay, so that's the end of the main presentation, and so there's a lot of information there to consume. But I'd like to talk to you before we go about some of the reasons that you might want to come and take some of the courses that NetCom are offering. And this is due to the fact that one of the things that you get to do when you come and take a class is that you get to play with some of the lab exercises. You get to play with lab exercises and actually physically use devices that you wouldn't normally use in your day-to-day organization's job. So one of the things that we're going to do with this, obviously, is it's going to validate your credibility as a professional, because you can actually say, yes, I passed this exam and so forth. But if you're a developer and you're going to be doing any sort of development in the environment, you'll need to master sort of the basic understanding of it. So if you're new to cloud or new to Azure specifically, then you'll want to take, the Azure fundamentals courses. And then from there, you'll take the data fundamentals and AI fundamentals. Those will give you the basics of the three major platforms that Azure provides you. And so it allows you to work your way through, and if you're starting off as a new developer, you can work your way through based on what you've learned in the classes and some of the hands-on experience that you get to them, as to how you're going to grow as a developer, and ultimately help you grow into a cloud administrator, cloud developer, so that you can take full advantage of cloud-based applications and services. The next one is the journey for the data and AI professionals. So it's still sort of the same foundations. You have to understand the basics of how it works and what the system can do. And then you can use that as a starting point to also grow into your role, to look at how you can create relational cloud databases as well as hybrid databases, and work with structured and unstructured data. And then also look at things like, what do I need to do to be a data engineer? What about a data scientist? And get certified in those sorts of things as well. It is possible also doing this to help grow your career by using Azure role-based instructor-led trainings. It's quite useful when I'm teaching a class to actually have a lab exercise that the students can go and actually say, oh, you know what you just told us works, or it doesn't work, or why am I doing this wrong, or that sort of stuff. But it gives you that environment and that place to play, to try things out that you wouldn't normally get to do on your normal day-to-day job. The instructor-led training, generally they are very interactive. So there's lots of discussion around real-world use cases and business contexts. Many of the trainers that Microsoft, let's try that again. Many of us people who are Microsoft trainers are also individuals who work in the industry. As an example, I am a pre-sales architect, so I do a lot of design and architecture and scoping and stuff for finance and operations projects, and so a lot of trainers also have experience. They're not full-time trainers; they also do training and as sort of a part-time thing. But you'll get their experience, their knowledge, and their day-to-day, what works, what doesn't work, kind of thing that you can extract from them. As part of the training, though, with that interaction, is you get 180-day access to virtual labs where you can practice and master different Azure skills. You will also get a free Azure Pass, or you'll get an Azure Pass that gives you X amount of access to Azure systems as well. You get, in this particular case for NetCom, you get a full year's worth of access to recordings of the classes, and full access to the learning portal and other free opportunities as well for things like free repeats and those sorts of things. So from a certification point of view, obviously it helps you stand out because, you get to say, I've been certified in this. And generally speaking, if you are certified, you tend to get greater recognition and a greater increase in pay. As the slide says, it's generally anywhere from 20 to 25% greater pay based on the certifications. And if you are in advanced certifications, such as cloud certification or architecture roles, that sort of stuff, you could increase your employability as well by, upwards of 50%, because by having those certifications, you prove that you actually have the ability to use those tools and that you know what they do and that they're what you can do with them in your organization. And then after you pass, you get the fun stuff. You get the badges that tell you that you're certified. And of course, you can then broadcast that information all over the world, Twitter, Facebook, and all that sort of stuff, LinkedIn. And then also notifications or gratification that you can add to things like LinkedIn. So, individual employee validations for different skills and different technologies that you can then use to advertise yourself in your organization. There is a handout that's available in the download area for the presentation today, and it's called "The Win-Win of Certification: How Employees and Businesses Thrive Through Continuing Learning." And just it goes through and talks about how an organization can improve itself, how you can keep staff, how you can make your company more efficient by completing a lot of these types of training sets, and qualifying and quantifying the knowledge that you've learned about specific type of courses and course materials that you've got. It helps to it talks about how training can improve timelines or timeliness, as well as business impact, how it can impact your career and make your professional livelihood that much better. And also it shows the direct correlation between continuous learning and better pay, better benefits, and so forth. And just basically how it can improve your job, make your life easier, make your life more interesting, because you get to play with all these different tools and you get to learn how to do new things that can be useful in the organization. And just some basic facts about certifications. One of the things that Microsoft has started doing within the last year or so is renewals. But renewals are not sort of as arduous as they used to be at one time. So when you go to write the exam the first time, you have to go to a testing center and you have to have a certified person monitor you to write the exam and all that sort of stuff. When the renewals occur, you'll get notified 6 months prior to your renewal starting, or your renewal expiring rather. And you'll have 6 months to complete that certification. That is done on the Microsoft Learn site on your own, self-paced, open book is even. And you just can't renew your certification if you don't pass the exam. And so if you pass the renewal assessment on Microsoft, this is a way to renew the certification. But if it's a new version or an updated version or whatever, you can't use that. But if you don't pass the renewal exam before that time frame and the expiration of your certification, then you have to go and take the full exam again. You don't get the option to take the renewal. So you must take that renewal prior to your certification expiring. And as I said, you'll get notice of it 6 months prior, so you'll have plenty of time to do the renewal. And lastly, basically, let's get trained. The more people that get trained in the tool, the better utilization capabilities you'll have, and the better people will A, think of the IT department, and B, be happier in your IT department. And that is it for me. So Leela, I will pass it back over to you.
Thank you so much, as always. You always do such a thorough job with it, and I know that we have so much more that could be covered. Just like you said, you really got to get these trainings, but we do appreciate the time that you take out of your schedule to talk to us. We're going to go ahead and jump right to our question and answer session. Let me get to the top of this list. we've got quite a bit of participation. So, I'm putting the cart before the horse. Before we do our question and answer session, so you still have time to get your question and answers in, we're going to hear from Sagnik. He is our director of vendor marketing, our manager of vendor marketing, and he's going to introduce some promotions and webinar related courses. Yeah, I got a little out of order there. Sagnik, are you with us?
Yes, ma'am. Good morning, everyone.
Thank you. I about skipped you.
Yeah, and you promoted me as well. I'm happy today. Someday. Yeah.
You should be able to share your screen. Oh, nope, sorry. I was trying to make somebody else the presenter. I saw the S and tried to give it to Sadia. There we
Great.
go.
Is my screen visible?
Yes, it is.
Okay, wonderful. Thank you so much, Leela. And thank you once again, Brent. It was an amazing session. As always, no surprises there. So very quickly, I'll take this opportunity to take our participants through some of the useful collaterals that we have put together for all these wonderful people. First and foremost, all the participants of this session are going to receive this handout. This is a very handy collateral that we have developed for you. It will contain some of the important information and resources that are related to the training that you just received. It was a free 2-hour masterclass, but of course, within the scope of it, it's so huge, the actual topics and the courses and the way Microsoft has designed these official courses. So you get to learn what is suitable for you and go accordingly. So in this collateral, you'd also get to know a little bit about us as well, NetCom Learning. We are a gold level managed learning partner with Microsoft, but we also hold authorized training partner status for all the top leading technology and business vendor and solution providers in the industry, right from Cisco, AWS, PMI, Axelos. We have every vendor on board. So whatever your training requirements are across domains and verticals, we have got you covered. As part of this deck, you'd find the link to the recording of this session in case you want to refresh the learnings here, or in case you want to share it with someone else as well, or especially for participants who couldn't attend the session in person. So this would be a handy reference back too. Another aspect of another perk of participating in a NetCom learning session is that you get access to the NetCom 365 learner portal. The accounts have been set up for all the registrations that we received. So please feel free to use the link that is provided within this handout to log in and activate your student portals. It would hold both your certificate of completion. So if someone is looking forward to take that document to validate that your participation in the session, you'd be finding that here, along with the free Microsoft official courseware that you have received as part of this masterclass session. You can also access the same there. I encourage you all to please go through the NetCom 365 portal and explore it. You'd find it worth your time. Some of the latest offers on official Microsoft training and certifications. For all the enterprise folks out there, if you are having a team that you're looking forward to upskill multiple participants, enterprise upskilling programs, basically, we have a special program designed specifically for enterprises called the Microsoft Skilling. It encompasses the entire official Microsoft training portfolio, so across products like Azure, Security, Microsoft 365, Dynamics 365, and Power Platform. You can get exclusive enterprise upskilling benefits when you decide to deploy a learning plan with us as your training partner. Privileges include up to 80% off exclusive enterprise discounts on learning plan deployments. we provide you a portal which is customized for your particular company so that it can be shared easily with your employees and they can enroll themselves on the courses that they want. You get the full-fledged access to the NetCom 365 portal, along with all the learners, the decision makers. They get access to separate NetCom 365 portals, which allows you to monitor the training and the learning journey of your employees, monitor their evaluations, their progress, the financials and the budgeting aspects of it, everything you get from the NetCom 365. Of course, it allows you to upskill across all the products and the solution areas: data and AI, digital and app innovation, infrastructure, security, business applications, modern work, you name it, we have it across the entire Microsoft portfolio. It is applicable. So it is a must. It is a great value for enterprises and decision makers and managers looking to upskill their teams. So please feel free to go through it. If it is applicable to you, feel free to schedule a free demo, and one of our learning consultants will take you through the details and the specifics. We have also a promotion running around the certification exam vouchers. As Brent rightly pointed out, the value of getting certified is multifaceted, both for the decision makers and the employees and the learners themselves. We recommend highly that you go through the Win-Win of Certification ebook. That is also part of the handouts that are provided, and the link is also there in this particular document. So feel free to go through that ebook and understand and look at what the data really says about the impact that certifications have across all these stakeholders. Currently, the discounted pricing offer is active. So for the fundamentals exams, you get around 40% off. So for $60, you get the exam vouchers. For advanced role-based exams, it's $124, which accounts to almost 25% discount. This offer is limited, is for a limited time. So if you have any urgent requirements, feel free to invest and enjoy this benefit before it is discontinued. The Win-Win of Certification ebook, you can find the link here along with all the handouts and the files that have been shared as from the GoToWebinar portal. There's also a NetCom Plus subscription that is primarily targeted towards individuals. So if you are an individual learner and you are in the align with the vision of continuous learning and lifelong learning, and your job requires you to be hands-on, this comes at a real value. So for $2,999 for an entire year, you get access to 500 plus training classes, including 60 official Microsoft courses. These are all instructor-led courses along with e-learning and everything. So it's the complete pack. You get access for an entire year, and you can take as many as 500 plus courses, instructor-led authorized official courses across vendors like Microsoft, AWS, Cisco, CompTIA, and many more. Feel free to explore that. Another option for enterprises is the Learning Passport. It's like you save up to 100% of your training fund value by investing upfront, and it is also valid for 12 months. It provides the organizations and enterprises the ability to train multiple members of their team and optimize their training budgets across the entire portfolio that NetCom Learning has to offer. So 4,000 plus official courses are part of this offering. Some of the recommended courses and events, something that Brent already enlightened us with, you'd find those links and handy here in this event handout. You can simply click on the things that resonate with your requirements, and you can enroll yourself or schedule a call with one of our advisors, and we'd be happy to help you out. If you are interested in further free master classes like this, upcoming 2 events are listed here: the Microsoft Dynamics 365 Masterclass, again a 2-hour masterclass. It is scheduled for March 12th, and the Microsoft 365 Masterclass, which is scheduled for April 23rd. Again, you'd also find some of the benefits of official Microsoft training with NetCom Learning. One of the exclusives is the 180-day access to the labs that are part of your role-based courses. So that gives you enough window to really practice, your skills as you learn for an extended period of time until you really get that confidence and that sense of mastering the skills. Please feel free to go through our social media handles as well. It would help you keep updated on the latest and the greatest from the world of Microsoft as well as NetCom Learning. And we look forward to your participation in all our upcoming events. And thank you so much for the time. Back to you, Leela.
Thank you so much. And now we can actually go ahead and get to those questions since I'm on time now. I'm not getting ahead of myself now. So we did have several people ask about certifications for this. There will be certifications sent. They are downloadable on Monday by email as well as the playback. Is that correct? I think that's how it works.
Yes.
On this one.
Yeah.
Yes.
Yeah.
Okay, and I did have one person ask, they were not able to join on time, so they just wanted to know if they will still be eligible for the certificate.
I would imagine so. I'll say yes.
Okay. If you have any troubles with it, just make sure you send us a message at webinar@netcomlearning.com. Let's see. This was from earlier in the presentation, right before our break, but they asked, is the entity a table name?
No. The entity is the collection and grouping of different values from different tables. Now, in Power Platform, they changed the naming thing. So, for instance, tables used to be called tables. They're now called entities. But from the purposes of the description that I was giving today, it was the conglomeration of different values from different fields make up an entity.
Wonderful, thank you. Let's see. Once we get to the end of our questions, we will wrap up. So if you do have any burning questions that you just need to ask, make sure you go ahead and get those in as quickly as possible. Our next question that we have is, when setting up a database, is it better to use Azure SQL or to create a VM with SQL on it and then use file storage?
No, you're better off using the Azure SQL instead of creating the virtual machine. It's less management because you don't have to manage the underlying infrastructure, and it'll be faster.
Awesome. So what is the difference between data lake and pipeline?
So the pipeline is the method that you're using to get the data in and out of the data lake and into the applications. The data lake is just the storage of the data that provides the pipelines the access to the actual data.
Thank you. Okay, looks like we've got a couple more questions here. What is the cost of storing data in the cloud?
Expensive. Especially if you're at the file service level, file store level, so like blob storage and whatnot, is considerably more expensive per gigabyte than Azure SQL. But you're probably the two biggest costs that you'll have when you're putting data into the cloud is data storage and networking. Those will be the two biggest costs. But they're expensive regardless.
Thank you. And here's a follow-up on that pipeline question. They wanted to know, so can we say any ETL lifecycle is a data pipeline?
Any ETL cycle would be part of the pipeline. It wouldn't be the entire pipeline, but it would be a portion of an existing pipeline that gets data from one side to the other.
Thank you. Let's see. I'm seeing one more question here. What is the advantage of using a tool like Cosmos DB?
So Cosmos DB is a very large, is a database system. It's an unstructured, non-relational table structure that is very, very, very fast. So for instance, as an example, if you're using financial services or like a bank or something of that nature, and you have many, many thousands of users connecting to the system, using a tool like Cosmos will give you much faster data access than using a tool like Oracle or SQL Server, just because of the way that the data is structured, and well, because the way that the data is not structured in the system, and gives you much faster throughput of the data requests that you do have. So using Cosmos DB for large data projects like that, so it's like financial data and those sorts of things, is much more advantageous than using traditional relational systems.
Thank you. And let's see, we did have one more question coming in about that, about the Cosmos DB. How is Cosmos DB different from SQL?
It's flat file non-relational versus relational.
Okay. Well, with that, that is all the questions that we have in our queue right now. So we're going to go ahead and wrap up. We did launch that poll previously. I don't know if they want to launch it again, just so the people who weren't able to take it can take it still. But we want to thank everyone for joining us today. If you do come up with any additional questions, please feel free to send them to us at webinar@netcomlearning.com at any time. And we hope that you all found today's webinar to be very informative. We look forward to seeing you back here really soon with us. Please tell your friends and colleagues about our other webinars and courses. And once again, thank you, Brent, for taking time out of your Saturday, and everyone for joining us. Have a wonderful weekend.